Okay, let's do another mixed factors ANOVA example in JASP. And in this example, after implementing our social emotional intervention with preschool teachers, we wish to examine if preschoolers' gender affects how problem behaviors change over time. And again, we've got pre-intervention, post-intervention, and beginning of the next school year. The first thing we want to do with our data set is go into descriptives, add our 3 problem behaviors to our variables, and add sex to our split. And under statistics, we want to check Shapiro-Wilk. And under customizable plots, we want to check box plots and label outliers. All right, and so when we come over here, we see for Shapiro-Wilk, for each time and each gender, the p-value of Shapiro-Wilk is greater than 0.05, so we can assume normality. And when we look at our 6 box plots, we do not see any outliers, so we do not have any significant outliers. The next thing we want to do is we want to run our repeated measures ANOVA. So we'll go into our repeated measures ANOVA, and I can change this repeated measures factor to time, and we want pre, and we want post, and we want year 2. Oops. All right, and I'm going to add in our problem behaviors, and I'm going to add in sex as our between subject factor. We want to check descriptive statistics, estimates of effect size. We want omega squared. Under assumption checks, we want sphericity with both corrections and the homogeneity tests. All right, so the first thing we want to do is we want to start with sphericity. And we go down here to our test and we see Mauchly's W of 0.665. That p-value is less than 0.001, so sphericity has been violated. We need Greenhouse-Geiser less than 0.75 or Hohenfeld greater than 0.75. So we can, with Greenhouse-Geiser, the epsilon is less than 0.75, so we can interpret the Greenhouse-Geiser correction in our output. For homogeneity of variances, we're going to look at our Levine's test, and we see that all 3 p-values are greater than 0.05, so we can assume homogeneity of variances. All right, so now to interpret the results, let's go to our main effect of time, and with Greenhouse-Geiser, the p-value is less than 0.001. All right, and we see, so we have a main effect of time, so at least one of the time comparisons is significantly different. The effect size is 0.044, so that's small to medium. For the interaction, the simple main effect, with Greenhouse-Geiser, we've got a p-value of 0.046, so we do have a significant interaction, but we see here that the effect size is very small. And then for the main effect of sex, we have a p-value of 0.153, and so the main effect of sex is not significant. All right, so the next thing we want to do is our post hoc comparisons for the time main effect. So we'll go over here to our post hoc tests, and we'll add time, and we want effect size, Bonferroni, and flag significant comparisons. So I scroll down here to our post hoc comparisons, and we see 3 significant p-values. So that means every time comparison is different. And so problem behaviors are decreasing significantly over time. They decrease from pre to post, they decrease significantly from pre to year 2, and they decrease significantly from post-intervention to year 2. All right, and now we want to do a post hoc comparison for our interaction effect. And the way we do that is we go to simple main effects, and we put sex as the simple effect factor and time as the moderator factor. All right, and what we're looking here is we're trying to find out if there's a significant difference between the sexes, boys and girls, at each time point. And we see here that we do not have any significant p-values. The reason being, how does this happen? Remember, this p-value is getting corrected. And so our significant p-value in the omnibus test is really close to 0.05, and the effect is really small. And so it's really not that surprising that by the time we go and look at this post hoc comparison here for the interaction effect, that we're not seeing any significant p-values. All right, and so let's blow this up. How do we report these results? All right, there were no outliers as assessed by box plot. The data were normally distributed as assessed by Shapiro-Wilks test of normality. And again, those p-values were greater than 0.05. There was homogeneity of variances. Again, the p-value was greater than 0.05 as assessed by Levine's test of homogeneity of variances. Mauchly's test of sphericity indicated that the assumption of sphericity was violated, and we reported the Mauchly's W with 2 degrees of freedom of 0.665 with a p-value of less than 0.001. The Greenhouse-Geiser correction with an epsilon equal to 0.749 was used for the interpretation of results. There was a statistically significant interaction between time points and sex when we report that F-test with the degrees of freedom for that test and with the residuals, and that F-test value was equal to 3.496 with a p-value of 0.046, and the effect size omega squared is equal to 0.003, showing a very small effect. There was a statistically significant main effect for time, and we report that F-test with value 350.228. The p-value is less than 0.001, and omega squared, or the effect size, was equal to 0.044, showing a small to medium effect. There was no statistically significant main effect for sex, and we report those non-significant results, the F-test, the p-value, and the effect size. Post hoc testing using the Bonferroni correction revealed that problem behaviors decreased significantly during and after the intervention, and we report those mean differences, the standard error, and the significant p-values for each of those comparisons. All right, at this point, you are ready for the homework.